In this video, we're going to talk about topic 5.6, and we're looking at example 8, and this is an extension problem. So for what value of k does the function f of x equal kx squared plus e to the sine x have a point of inflection at x equals 0? So I know the first thing I need to do is I need to get to the second derivative because it's talking about point of inflection. In order to get to the second derivative, I know I have a chain rule going on. So let's start with f prime of x equals, this here is k as a constant, so I'm going to just bring it 2kx, and then plus, and then I know that the u is going to be sine x, which means that u prime is going to be cosine x, and then when I do the y equals e to the u, my derivative is e to the u times the cosine x, and then when I bring that back over here, I get e to the sine x times cosine x. Now I've got to take the second derivative. So my second derivative, 2kx would just be 2k. Because remember, k is a constant. Here, I not only have the chain rule still hanging out, but I also have a product rule going on, so I have to deal with that. So the good news is the derivative e to the sine x is still e to the sine x cosine x. So I know the derivative of my red is going to be e to the sine x cosine x. And then I'm going to keep the green the way it is. So I'm just going to keep a cosine x. And then we're going to add. And I'm going to keep the red the way it is, which is e to the sine x. And then the derivative of the green would be negative sine x, because the derivative cosine is negative sine. All right, then we are supposed to be showing where we're supposed to be finding where the x value is 0. So I'm going to actually plug 0 into this thing and try to solve for k. And then, so I'm going to do hold on, let me write that out a little differently. So I'm going to find where f double prime of 0 equals 2k plus e to the sine of 0, cosine of 0, cosine of 0, minus e to the sine of 0, sine of 0. And then we know that to get the critical numbers, that has to be equal to 0. So that's how we're going to get to solve for k. If I look at sine and cosine at 0, I know that sine of 0 is 0. So I've got 2k plus e to the 0. Cosine of 0 is 1, so these are just 1 times 1, minus e again to the 0 times sine of 0, which is going to be 0. So I know this term cancels. E to the 0 is just 1, so I've got 2k plus 1 equals 0. So 2k equals negative 1, so k is equal to negative 1/2.